Imagine a simple mixture costing just $1 that can bring plants on the brink of death back to full vitality within 72 hours. Not slowly feeding them over weeks, not giving a temporary boost for a few seconds, but truly reviving plants showing severe nitrogen deficiency, yellowing leaves, stunted growth, and weakened roots. One treatment, applied either to the soil or directly onto foliage, triggers chlorophyll production, sparks new growth, and regenerates root systems. In 1978, a botanical researcher at Cornell University experimented exclusively with this formula on tomato plants deliberately starved of nutrients. Within 96 hours, the plants transformed from complete chlorosis to lush green foliage. The turnaround was so astonishing that the scientists first suspected a contamination in the lab. The global gardening products market now exceeds $48 billion every year. Fertilizers, soil enhancers, plant foods, and specialized treatments make up $19 billion of this total. Home gardeners typically spend around $230 annually on products claiming to boost plant health. The industry thrives on slow-release formulas, repeated applications, and targeted solutions for different species. A single dollar of a universally effective mixture cannot be marketed as a high-end product. It cannot foster repeat purchases. It cannot create a multi-product empire. This is the story of Epsom salt and its role in the nitrogen cycle, knowledge that the gardening industry has long suppressed. Back in 1695, a spring in Epsom, Surrey, England, gained fame across Europe for its remarkable healing powers. People traveled from distant regions to bathe in the water or drink it for wellness benefits. Nehemiah Grew, a local chemist, analyzed the spring and found it contained high levels of magnesium sulfate, a naturally occurring mineral compound. He published his results, and the substance became known as Epsom salt. By 1750, physicians throughout Europe prescribed it for ailments ranging from muscle pain to digestive issues. Meanwhile, farmers noticed that crops irrigated with water from the springs flourished far better than those using other sources. Fields nourished with Epsom water exhibited deeper green foliage, more vigorous growth, and higher yields. Gardeners soon began diverting the spring water intentionally to their vegetable gardens and ornamental plants. The effect was unmistakable, and by 1830, agricultural chemists had established the link. Magnesium is central to chlorophyll formation, with a magnesium atom at the heart of each chlorophyll molecule. Without sufficient magnesium, plants cannot generate chlorophyll no matter how much nitrogen, phosphorus, or potassium they receive. Sulfur is equally crucial for protein synthesis and enzyme activity. Epsom salt supplies both magnesium and sulfur in a highly soluble form that roots absorb almost instantly. By 1880, commercial agriculture had widely adopted Epsom salt. Farmers applying it to magnesium-deficient soils observed immediate improvements in crop quality and yield. Yet home gardening took a different course. By 1950, chemical fertilizer companies were producing synthetic blends of nitrogen, phosphorus, and potassium, marketed as complete plant foods. These NPK fertilizers became the industry standard. The flaw was that many NPK formulas left out magnesium and sulfur entirely, or included them in forms that released too slowly. Plants suffering from magnesium deficiency continued to decline, despite additional NPK fertilizer applications. Gardeners then bought more products, switching brands and formulations in search of a solution. This cycle perpetuated indefinitely, generating continuous revenue. If everyday gardeners discovered that a single $1 bag of Epsom salt could resolve most common plant health issues immediately, the market for premium fertilizers, specialty plant foods, and emergency treatments would collapse. The industry recognized this risk and acted to suppress the knowledge. By the 1960s, gardening magazines stopped publishing articles on Epsom salt, horticultural textbooks removed references from nutrition chapters, and garden center employees were trained to recommend branded products instead of simple mineral supplements. Yet the wisdom survived quietly among older gardeners who remembered pre-commercial agricultural practices, passing it down informally. Now, having understood this, you know far more about plant nutrition than most retail staff in garden centers. Every hidden technique the gardening industry tried to bury is stored within the comprehensive forbidden camping vault. The compost tea that outperforms any bagged fertilizer and nutrient delivery. The companion planting strategy that cuts pest infestations by 90%. The mulching system that slashes watering requirements by 70%. The soil structuring approach that doubles root expansion without any additional amendments. The seed germination method, achieving 95% success. And finally, the Epsom salt mixture, capable of bringing dying plants back to life in 72 hours. 6 powerful gardening methods contained in one vault without any filler, each designed for instant use. But the real marvel lies in the plant biology behind Epsom salt, which is truly shocking. When magnesium sulfate dissolves in water, it instantly separates into magnesium ions and sulfate ions. As soon as this solution reaches the roots or is absorbed through leaves, both ions move directly into the plant's vascular system. Magnesium ions are transported to chloroplasts, where chlorophyll is synthesized. Chlorophyll itself is a porphyrin ring centered around a magnesium atom. Without magnesium, plants cannot complete this molecule, halting photosynthesis. When this process stops, the plant can no longer convert sunlight into chemical energy. Growth ceases, leaves yellow as existing chlorophyll deteriorates and cannot be replaced. Once magnesium becomes available, chlorophyll production resumes within hours. Fresh molecules form, the green color returns to leaves, and photosynthesis restarts. The plant regains the ability to convert sunlight into sugars, fueling new growth. Sulfate ions are equally vital. Sulfur is a key element in the amino acids cysteine and methionine. Without sulfur, amino acid synthesis halts, protein formation stops, enzymes fail, and all cellular processes grind to a halt. Deficiency in sulfur shows symptoms similar to nitrogen shortage because both limit protein production. Once sulfate is present, amino acids form again, proteins are synthesized, enzymes reactivate, and cellular metabolism returns to normal. A landmark experiment in Hort Science in 1994 tested Epsom salt applications on tomato plants grown under controlled greenhouse conditions. Researchers planted tomatoes in magnesium-deficient soil, splitting them into 3 groups. The control group received no supplements. Another group received standard commercial NPK fertilizer. The final group was treated with 1 tablespoon of Epsom salt dissolved in 1 gallon of water, applied to the soil every 2 weeks. After 8 weeks, the control plants displayed severe chlorosis, stunted growth, and poor fruit development. Plants receiving NPK fertilizer improved slightly, but yellowing persisted, and growth remained limited. In stark contrast, tomatoes treated with Epsom salt fully regained green foliage, vigorous vegetative growth, and fruit production comparable to plants grown in optimal soil. Tissue analysis revealed magnesium content in Epsom salt plants was 2.3 times higher than in NPK-treated plants. Chlorophyll levels were 87% greater, and fruit yield surged 143%. The study concluded that magnesium sulfate provided benefits that conventional NPK fertilizers could not replicate. Despite being published in a specialized horticultural journal and cited in academic literature, these findings were ignored entirely by the consumer gardening industry. Here's why Epsom salt works faster and more effectively for plant rescue than standard fertilizers. NPK fertilizers focus on nitrogen, phosphorus, and potassium, often in slow-release formulations designed to feed plants gradually over weeks or even months. This slow release is marketed as a benefit, preventing fertilizer burn and providing sustained nutrition. But for plants in acute distress with severe nutrient deficiencies, slow-release formulas mean delayed recovery, sometimes death. Epsom salt, in contrast, dissolves fully and immediately in water, making magnesium and sulfur instantly available to roots and foliar tissues. No waiting, no gradual feeding. Upon contact, deficiencies start to correct themselves immediately. Additionally, most commercial fertilizers concentrate exclusively on nitrogen, phosphorus, and potassium because these macronutrients are needed in large amounts. Yet plants also require secondary nutrients, including calcium, magnesium, and sulfur, along with micronutrients like iron, manganese, zinc, copper, and boron. Magnesium and sulfur shortages are extremely common, but are almost never addressed by conventional NPK fertilizers. A plant may receive plenty of nitrogen, phosphorus, and potassium, yet still wither and die if magnesium is lacking, because chlorophyll cannot form without it. Epsom salt tackles the real cause, instead of simply adding nutrients that are not limiting. Here is a precise guide on how to prepare and apply this mixture to restore dying plants. Epsom salt can be purchased at any grocery store or pharmacy. A 4-pound bag costs about $4 and is sufficient for roughly 100 applications. For soil treatment in outdoor gardens or potted plants, dissolve 1 tablespoon of Epsom salt in 1 gallon of water. Stir until fully dissolved, then apply the solution directly to the soil surrounding the root zone. Treat it like ordinary watering, ensuring the mixture reaches all roots. For most plants, use 1 cup of solution per square foot of soil or per 6-inch pot. Repeat the treatment every 2 weeks throughout the growing season. In urgent cases where plants are severely stressed or showing yellow leaves, double the dose to 2 tablespoons per gallon and apply immediately. For foliar application, which produces even faster results for plants in crisis, dissolve 1 tablespoon of Epsom salt in 1 gallon of water and transfer to a spray bottle. Spray leaves directly, covering both the top and underside thoroughly. Apply in the early morning or evening to prevent leaf burn from sunlight. Foliar application delivers magnesium and sulfur directly into leaf tissues, bypassing roots. This method is particularly effective for plants with weakened root systems or those in rapid decline. Results are visible within 1 to 3 days. Certain plant types show especially dramatic responses. Tomatoes benefit greatly, receiving 1 tablespoon per foot of plant height, dissolved in water every 2 weeks during the growing season. As heavy magnesium feeders, they respond strongly to supplementation. Roses also react well. Apply half a cup of dry Epsom salt worked into the soil at the base of each bush in early spring, and again after the first bloom. Peppers experiencing blossom end rot, often caused by magnesium deficiency rather than calcium, recover within 1 week when sprayed with Epsom salt solution. Houseplants with yellow leaves and stunted growth respond to monthly watering with the solution. Seedlings that appear pale or weak show rapid greening and vigorous growth when foliar sprayed with a half-strength solution. A North Carolina home gardener documented the complete revival of a dying vegetable garden in 2015 using this approach. The garden was a raised bed system of 24 square feet containing tomatoes, peppers, cucumbers, and herbs. In July, all plants displayed severe yellowing, leaf drop, and ceased growth despite regular watering and commercial fertilizer applications. The gardener had already spent over $60 on various rescue products with no improvement. As a final effort before removing the plants, she applied Epsom salt solution at 2 tablespoons per gallon, thoroughly watering each plant and spraying the foliage. Within 48 hours, new growth at stem tips turned green. Within 5 days, yellow leaves started regaining color from the center outward. 2 weeks later, all plants exhibited vigorous new growth, resumed flowering and fruiting, and produced normal yields for the rest of the season. The total cost for the Epsom salt used was only $1.30, while the commercial rescue products had cost $63 in total. This knowledge did not vanish because it ceased working. It vanished because it worked so effectively that a $19 billion fertilizer industry had to ensure home gardeners never discovered that most plant problems result from magnesium and sulfur deficiencies, correctable with a $1 mineral supplement. For 70 years, gardening companies understood that Epsom salt addresses root causes while their products merely treat symptoms. Yet a complete solution costing only $1 cannot support continuous revenue streams necessary for product development, marketing, and retail distribution. The chemistry has been documented in agricultural science since the 1800s. Its effectiveness has been proven in controlled experiments, and its safety has been established through centuries of use. But a solution costing $1 that permanently solves the problem cannot coexist with a business model built on selling specialized products for every plant type and problem. So it was buried under decades of marketing for NPK fertilizers, slow-release blends, and premium plant foods that omit the very nutrients most plants actually lack. This suppression was methodical, institutional, and almost completely successful. Every dying plant now represents a hidden opportunity unlocked by understanding this truth. Take action now. Apply this knowledge to your garden, share it with others, and let the secrets of effective plant revivals spread beyond the walls the industry built. Thanks for watching. See you in the next one.